Welcome to the DIY Honda Garage channel. This presentation addresses Diagnostic Trouble Code, DTC P2270, related to the secondary heated oxygen sensor, HO2S, in Honda Civic models from 2006 to 2011. The P2270 code indicates that the signal from the secondary HO2S circuit is stuck too lean, meaning the sensor is sensing a higher oxygen level than expected. In a typical setup, the secondary HO2S is located after the catalytic converter and functions to monitor the efficiency of the catalyst. If the signal is stuck lean, it can result in improper fuel trimming by the engine control module, ECM. Understanding this code is crucial for ensuring accurate emissions readings and optimal engine performance. DTC P2270 and P2271 are both related to the operation of the secondary heated oxygen sensor, HO2S, also referred to as Sensor 2. The primary function of this sensor is to monitor the level of oxygen in the exhaust gases after they have passed through the catalytic converter. This data is essential for the engine control module, ECM, to adjust the air-fuel mixture accordingly. The sensor is typically mounted in the exhaust system downstream of the catalytic converter, ensuring it measures the efficiency of the converter by indicating whether it is maintaining proper emissions levels. A stuck lean condition, P2270, or a stuck rich condition, P2271, can cause significant issues in emissions management, leading to increased pollution and potential fuel inefficiency. Several possible causes exist for DTC P2270 and P2271. First and foremost, a faulty secondary HO2S sensor can directly lead to these trouble codes. If the sensor is defective, it may send incorrect signals to the ECM, causing it to mismanage the air-fuel ratio. Another potential issue could be damaged wiring or connectors that link the secondary HO2S sensor to the ECM. If the wiring is frayed or connectors are corroded, they may provide intermittent signals or completely fail to transmit data. Lastly, problems can also arise from issues within the ECM or Powertrain Control Module, PCM, which could incorrectly interpret the signals received from the HO2S sensor, leading to erroneous adjustments in the engine operation. Symptoms associated with DTC P2270 and P2271 can vary, but commonly include poor engine performance. When the secondary HO2S sensor malfunctions, the vehicle's ability to manage its air-fuel ratio suffers, often leading to noticeable sluggishness or hesitation during acceleration. In addition, increased emissions are a significant concern, as a malfunctioning sensor can mislead the ECM, resulting in higher exhaust pollutants. Another symptom to look out for is declining fuel efficiency, often manifested as decreased miles per gallon. Your Honda Civic may begin to consume more fuel than usual as the engine attempts to compensate for the incorrect data being reported by the faulty sensor. The first step in troubleshooting DTC P2270 is to turn the ignition switch to on, which powers the electrical systems without starting the engine. This initial phase is crucial for collecting all available freeze-frame data from the vehicle's onboard diagnostics. Freeze-frame data helps technicians understand the conditions under which the fault occurred. Following this, it's important to review the general troubleshooting information provided in the service manual, as it may contain important diagnostic steps tailored to the specific code. Assessing this information allows for a more focused approach to diagnosing the issue, potentially saving time and resources. Next, the DTC should be cleared using the Honda Diagnostic System HDS. HDS is a specialized tool that allows technicians to communicate with the vehicle's onboard systems, providing the capability to read and clear diagnostic trouble codes. This step prepares the vehicle's systems for a fresh diagnosis by removing any previous DTCs. After clearing the code, the technician should proceed to the next step of starting the engine. This process is vital for observing if the same DTC reoccurs, indicating that there might still be an underlying issue with the secondary HO2S sensor or related components. Once the engine is started, it is necessary to let it idle without load. In automatic transmission vehicles, this means shifting into park, P, or neutral, N, while manual transmission should be in neutral. The goal is to allow the engine to warm up to operating temperature, specifically until the radiator fan engages. This indicates that the engine coolant temperature has reached a sufficient level for accurate sensor readings. Establishing these warm conditions is crucial for properly assessing the performance of the secondary HO2S in later steps, as it provides the necessary environment for optimal sensor functionality. The fourth step involves taking the vehicle for a test drive while meeting specific operational conditions. The engine coolant temperature, ECT, must be above 158 degrees Fahrenheit, 70 degrees Celsius, indicating that the engine has sufficiently warmed up. This is critical because sensors like the secondary HO2S perform best at higher temperatures when the engine is fully operational. Additionally, the vehicle's speed should exceed 35 miles per hour, 56 kilometers per hour, for at least 1 minute to ensure the sensor can accurately read the exhaust conditions at highway speeds. This test drive aids in determining whether the DTC P2270 or P2271 reoccurs, giving insights into the functionality of the HO2S sensor under load. During this step, it's essential to monitor the onboard diagnostics (OBD) status using the HDS. This will display whether DTC P2270 or P2271 is indicated again. If the diagnostic results indicate failed, this suggests that there is indeed an ongoing issue requiring further inspection. Conversely, if the results show passed or indicate that the situation is intermittently failing, there may not currently be a fault. In that scenario, it can indicate that the sensor or its connects might have a poor connection or loose terminals, often leading to intermittent readings. In this part of the procedure, turn the ignition switch to lock 0. Ensuring the vehicle is completely turned off is vital for safety before any repairs or replacements are conducted. This step is crucial as it allows for secure handling of electrical components without the risk of accidental shorts or injury. The step prepares the technician for replacing the secondary HO2S sensor, which could be faulty based on the previous observations. Proper precaution must be taken to avoid damage to surrounding components, maintaining the integrity of the exhaust system. At this stage, the actual replacement of the secondary HO2S sensor occurs. It's imperative to use the correct tools and follow manufacturer guidelines to ensure that the new sensor fits properly and functions correctly. Improper installation can lead to future DTCs or sensor failures. During this process, the technician must also inspect the wiring and connections, ensuring that no additional damage has occurred. Once the new sensor is in place, confirm that it is securely connected to prevent issues in the future and facilitate accurate readings from the ECM. With the new secondary HO2S sensor installed, the ignition switch is turned back to the on position. This activation prepares the electronic systems of the vehicle for the next series of diagnostics and adjustments. At this stage, ensuring that all systems are functioning properly is paramount for a successful troubleshooting process. The technician should be alert to any warning lights or irregularities that might indicate further issues that need addressing. After this, the vehicle's engine control module, ECM, can be reset using the HDS, recalibrating its functions for optimal performance. Resetting the Engine Control Module, ECM, or Powertrain Control Module, PCM, using the HDS is essential, following the replacement of the secondary HO2S sensor. This reset clears stored diagnostic trouble codes and ensures that the module starts with fresh data. The reset process involves using the HDS to erase all fault codes that may have been generated before the sensor replacement. After the reset, the ECM integrates the new sensor's data for accurate fuel management. This also prepares the vehicle for the idle learn procedure, which helps the ECM adapt its parameters to the new sensor. After resetting the ECM/PCM, performing an idle learn procedure is a critical step. This process allows the ECM to recalibrate its settings based on the data received from the new secondary HO2S sensor. It is important for maintaining proper idle conditions and overall engine performance. The idle learn procedure optimizes the fuel-air mixture based on real-time feedback from the newly installed sensor, allowing for responsive engine control. Without this step, the vehicle may experience erratic idling and performance issues, as the ECM could still be trying to work with outdated settings. Hence, this step is vital for achieving the best operational standards. With everything set, the technician should start the engine once more and allow it to idle without load. Similar to previous steps, this idle must continue until the radiator fan turns on, indicating that the engine has reached its operational temperature. This is an essential part of ensuring that the ECM receives accurate data from the secondary HO2S sensor. During this period, the technician should watch for any warning lights that may be indicative of existing issues. If everything operates smoothly, it's a positive sign that the recently installed sensor is functioning correctly, setting the stage for further evaluations. The 12th step requires taking the vehicle for yet another test drive, ensuring that it meets the same stipulated conditions as before. The engine coolant temperature, ECT, must be maintained above 158 degrees Fahrenheit, 70 degrees Celsius, alongside achieving a vehicle speed greater than 35 miles per hour, 56 kilometers per hour, for at least 1 minute. This is critical for assessing the new secondary HO2S's functionality. By simulating real-world driving conditions, technicians can observe if the new sensor properly communicates data back to the ECM. It's important for ensuring that the air-fuel mixture remains optimized and that the vehicle's emissions are within acceptable ranges. Upon completing the test drive, it is crucial to check for any pending or confirmed Diagnostic Trouble Codes, DTCs, through the HDS. This step is significant in determining if DTC P2270 or P2271 has recurred after the installation of the new secondary HO2S sensor. If these codes are once again indicated, it suggests that there may still be issues related to poor connections or loose terminals between the secondary HO2S and the ECM/PCM. Therefore, a thorough visual inspection should be conducted to ensure all connections are secure and undamaged. This step is essential for confirming that the repair has resolved the initial fault and for ensuring ongoing reliability. The final step involves monitoring the OBD status on the HDS once more. Here, the technician determines if the screen indicates passed for DTC P2270 or P2271. If the status is passed, it signifies that troubleshooting is complete and the vehicle has successfully rectified the issue. However, if any other pending or confirmed DTCs appeared during the previous checks, those will need to be addressed accordingly. If the screen shows failed, it would indicate a need to revisit the diagnostic steps. Each component must be double-checked for connections, and the technician should be mindful of environmental conditions that might affect sensor operation. Completing this step ensures an effectively resolved issue. In the final verification process, it's paramount to check all connections once again to ensure everything has been reassembled correctly. This includes confirming that the wiring harness to the secondary HO2S sensor is intact and securely connected to the ECM/PCM. Any loose or corroded connections could lead to premature failure. Next, assess the functionality of the newly installed sensor by reviewing real-time data during engine operation. Finally, confirm that all Diagnostic Trouble Codes, DTCs, are cleared, indicating that there are no lingering issues with the vehicle's emissions control system. This step is critical for guaranteeing the health and longevity of the repair performed. To prevent future occurrences of DTC P2270 or P2271, routine preventive maintenance is essential. Regular inspections of the secondary heated oxygen sensor, HO2S, can identify wear and tear before they lead to failures. This consists of checking the sensor's condition, ensuring it is not clogged or damaged. Additionally, periodically examining electrical connections can prevent intermittent failures stemming from corrosion or loose terminals, which often leads to inaccurate sensor readings. Further, maintaining the entire exhaust system in good working order is crucial for ensuring all components work harmoniously. Such proactive measures can ultimately prolong the lifespan of the sensor and enhance overall vehicle performance. In conclusion, understanding the role of the secondary heated oxygen sensor, HO2S, is fundamental for effectively diagnosing and addressing DTC P2270 and P2271. Following the systematic troubleshooting steps outlined ensures an accurate diagnosis and promotes effective repairs. The importance of regular maintenance cannot be overstated. It not only avoids future issues, but also preserves vehicle performance. Ensuring that all aspects of the oxygen sensor and related systems are in optimal condition is vital for maintaining fuel efficiency and meeting emission standards. By embracing these practices, Honda Civic owners can ensure their vehicles operate at peak efficiency and reliability for years to come. Please like and subscribe to the channel. See you next time.